My name is Sam Bowling. Along with my team, we will be presenting our assembly analysis for the Ender 3 Pro 3D printer, specifically the X-axis gantry subassembly. Here is a brief overview of our presentation. First, we will give a description of the product, including an exploded view of the CAD model and some highlights from the bill of materials. Then we will describe our two key characteristics and finally present the liaison diagrams for each KC. As I stated before, our product is the Ender 3 Pro 3D printer. From this product, we specifically chose the X-axis gantry on which to conduct an assembly analysis. The purpose of the gantry is to travel along the Z-axis as well as move the nozzle assembly along the X-axis. In order to successfully print parts, the gantry must have precise and repeatable alignment to the print bed and allow for smooth movement along the X and Z axes.
As can be seen in the exploded CAD diagram, the subassembly to be analyzed consists of a main gantry beam to which all other parts are attached. Almost all connections other than the moving nozzle assembly are rigidly bolted together. On the right end of the beam, a larger plate and 3 rollers for travel in the vertical direction are connected. On the same end but the opposite side, a passive belt roller is attached through a smaller plate. On the left end of the beam, 2 plates bolt together with rollers in between. These plates also provide a mounting position for the material receiver and X-axis servo motor. Finally, the nozzle subassembly travels across the beam through 3 rollers. Looking at the key parts of this abbreviated bill of materials, you can see most parts are relatively simple to manufacture. This can help in the case of demanding tolerance requirements. The gantry beam is extruded with connecting holes drilled afterwards, and all plates can be manufactured with 2D plate techniques such as stamping or water jetting. There's one lathe part and a couple made through injection molding, but besides that, the rest of the unlisted parts are fasteners, which are usually outsourced. The servo motor is likely to be bought from a dedicated manufacturer as well. Most assembly steps are simple attachments by bolting, leaving the order of assembly open other than leaving a couple rollers off until the end so they can wrap around the travel beams.
The first KC we define is the center-to-center distance between 2 outer travel rollers. This dimension is critical since it determines whether the gantry can be installed on gantry legs properly. By design, the rollers can move up and down in the Z-axis along the groove on the outside of the gantry legs. If the KC is less than the requirement, the gantry legs on both sides will not fit between the outer rollers, which will result in gantry unable to assemble. If the KC is greater than the requirement, the roller will not provide sufficient support and the gantry will slide down from the legs. KC1 is established by the connection from the following 5 parts: the right-hand side travel roller, the passive roller plate, the X-axis gantry, the interior motor plate, and the left-hand side travel roller.
KC2 is defined as the distance between motor shaft belt pulley on the left side of the beam and passive belt roller on the opposite side. Normal distance of it must be 14.909 inches to ensure sufficient belt tension. Lower tension may cause slippage during extruder travel, resulting in incorrect nozzle position and poor printing quality. Higher tension may prevent proper assembly of the product and decrease functional belt life due to higher stress. KC2 is formed by the connection from the following 7 parts: the servo motor, the motor shaft pulley, the left-hand side plate, the gantry beam, the roller plate, and the belt roller.
The liaison diagram for key characteristic 1 contains 3 nodes. It is determined by the distance between node A and B, representing the right-hand side outer roller assembly and the left-hand side outer roller assembly, respectively. C is the gantry beam to which A and B are mated and fully constrained. The liaison diagram from key characteristic 2 appears more complicated with 6 nodes, but is broken into 3 sections. KC2 is the distance between subassembly 1 and 3, with subassembly 1 comprised of the motor shaft housing and the motor shaft belt pulley, and subassembly 3 being comprised of the passive belt roller at the end of the crossbeam. There's also subassembly 2 comprising of the nozzle subassembly and the G roller bearings and gantry. Subassembly 1, 2, and 3 are all mated to node C, which is the horizontal cross beam and belt assembly. The possible KC conflicts: if the KC's lengths differ too greatly, they may interfere with the 3D printer or plate design, and the nozzle maximum travel distance.